All right. Hey, everybody. So this is Benson on Board Desmos Lab Part 2. So in this video, I'm going to talk about the prediction and your conclusion. So we've already graphed it. On this slide, we need to make a prediction about my location after 9 seconds. So if we go back to our graph, here's our graph. Yours might look a little different. That's okay. And if I go down here, because the y-axis or the x-axis is time, if I go to 9 seconds and travel up until I reach my best fit line, that is going to be my prediction for how far I'm going to travel in 9 seconds. So if I go over, that's 12 meters. So 12 meters, I'm going to go back to here, 12 meters. And then this over here, you need to say if your prediction is high, medium, medium low, medium, or medium low. So if we look at this, I picked a data point that was directly on my best fit line. So here it says the best fit line is near the center of most data points. That is true. And my prediction is within data range. So it's right next to the best fit line. So I'm going to circle high. All right, let's go ahead and go on. So this slide, I'm not going to spend a lot of time here because this doesn't relate directly to our data, but you are supposed to figure out which one of these graphs and equations correspond to a medium speed push, a slow speed push, and a fast speed push. So if you think like, so if we look at this graph, our line is pretty flat, like it doesn't have a really steep slope. So you might say, okay, I think that that's the slowest. All you need to do is drag and then put it on the other one. So you're going to sort the rest of them into these 3 categories. All right, and slide 13, this is the one I wanted to spend the majority of our time on. So this is your conclusion. This is what you're going to use to write your conclusion in your lab report. So this first one says, make a claim about the motion of Mrs. Benson. Do you think she was rolling at a constant speed, or do you think her speed was changing? So if we look at our data, this line here, although this last data point was a little bit lower than the other ones, most of them are in this straight line. And when data points are in a straight line, that tells you that it was pretty constant. So I'm going to write for my claim, Mrs. Benson's motion was constant. And if you wanted to write about that last data point that's a little bit lower, so maybe I was slowing down a little bit because of friction, you can. All right, and this one, identify what parts of the graph help support your claim. So the graph supports this claim because the best fit line is linear and almost all data points touch the best fit line. And here again, if you wanted to talk about the data point, the last one that's a little bit lower that indicates that I've been slowing down, that's okay too. All right, our mathematical model for this pattern, if we go back to our graph, here we go, D equals 1.33 T. Go down, D equals 1.33 T. And then write a description of what you think the A value tells us about Mrs. Benson's motion. So I am going to let you answer this one because I want to see what you have to say, but I'll start you off with a sentence frame. I think the A value tells us that, and you can answer. All right, and then last one, write down your prediction of how far Mrs. Benson will go in 9 seconds. So we already did that. I predict that Mrs. Benson will travel 12 meters in 9.0 seconds because that is the point on my best fit line. All right, and then you'll hit submit. So the last thing you need to do, this is your homework. This is going to be due by next Wednesday. Under classwork period 4, you've got this homework lab report. If you click on this, you are going to copy all of your Desmos information to your lab report here and then turn it in. All right, if you have questions, remember, email me at any time. I'm happy to help, and I will see you soon. Bye-bye.